Let's say you need to control a pump or a water valve to do watering for your garden, irrigation, anything like that. You could also expand this to do other things like look for a flooded basement, what have you. And that's what this setup is designed to do. We've got a probe over here. We'll go into more detail in a minute. We've got our Raspberry Pi. We've got an alert light. We've got our solid state relay. We've got our pump. Or in case of watering, if you don't need a pump, maybe you just need a valve to turn on and off. And then we have a power supply to run the pump. Okay, so let's take a closer look at each of the components and see what we got going on. What's going to happen is based on our software, which you can see running in the background. When the soil sensor dries out, the warning light will come on, and then the pump will come on. And when the ground is saturated, the warning light will go out and the pump will go off. Let's take a look at our circuit. I will include a circuit diagram, this circuit diagram, at the end of the video, so don't worry about trying to figure out what's going on with all these wires, at least from this part of the video. This is our soil probe. As I mentioned earlier in another video, this thing is plated in lead. It's very cheaply made. It breaks down very quickly. So this should never be used where plants are going to be eaten or whatever because the lead will transfer to the plant. So don't do that. You'll need a stainless steel probe. Okay, that travels down to this sensor board. The sensor board decides whether this probe is wet or dry and sends a signal then over here to the Pi. And based on whether this signal is 1 or 0, high or low, the software is going to look at that and then decide what actions to make. And for example, one of those actions will be to turn on this warning light if the soil is dry, as you can see there. And so this side of what we're looking at is all about the Raspberry Pi. And then what's going to happen is these two wires that go over here are going to trigger the other half of this circuit, or actually a separate circuit that will control the pump. Okay, let's look at that. The other side of this table, let's scan across here, is really, this part over here is really an independent circuit. And what's happening is the Raspberry Pi is turning on or off this solid state relay, which supplies power to the pump or water valve, whatever you're going to do, through this power supply over here. And that's what's happening. There's really two separate circuits. There's this pump or water valve circuit that is controlled by this solid state relay. And then there's the Raspberry Pi circuit, which is over here off camera now. And what's going to happen is when the sensor says, hey, it's dry, the software in the Raspberry Pi is going to make a decision on whether to turn this solid state relay on or off. And that's pretty much all there is to this. Now, we could expand that. There are more pins on the Raspberry Pi. We could have it do many things. We could have it control many different pumps and look at different sensors and so forth. But this basic setup is easily expandable. You can replicate what's going on here and add different components as you need. Let's take a look at the software. This was written for Python 3. This is an advanced version of an earlier program that I wrote to do. The earlier one was very basic. All it did was monitor the soil moisture. When the soil got wet, it would turn on an LED. This one does that, plus it does pump control or water valve control, as we shall see. So this is a more advanced version. It's going to turn on a pump or a electric valve. And it's also, this one also includes a limitation for time of day, so you can say only water at night, so you'll save water by doing that. This is going to require a clock module or internet access for time, since the Raspberry Pi does not keep time by itself. When you turn the power off on the Raspberry Pi, it loses the time. And so if you start the Raspberry Pi and it has no internet connection, it will have the wrong time. Okay, VCC pin 1 is 3 volts, our sense pin for our module is pin 7, and our ground pin for that module is pin 9. This is going to activate an LED pin, as I said earlier, on pin 36, and it's grounded on pin 34 when the moisture is low. Activates water valve or pump on pin 16 and grounded on pin 14 when there's low moisture. And I should include this warning again, the probes they contain lead, so you never want to use these probes that are included in these cheap kits for food or anything where you'll be giving the plants or whatever to humans or animals. If you're going to do this long term or on a serious basis, you need to have a stainless steel sensor. Miswiring your Pi can damage the sensor or the Pi, and this information is given as is, so how you use it is up to you. We're going to import the rp.gpio so we can use the GPIO pins, and we're going to import time because we need the clock and we also need to know the date time. Okay, let's move down. The next part will declare our variables and we'll set up our GPIO. Nighttime is the time after which you want the watering to start. Now you say, well, that's set for early in the morning. Yes, because I'm making this video early in the morning and I need the pump to turn on for the demonstration. But you could set this, say, for 8 o'clock at night, which would be 2000 hours, 2000, something like that. Sensor pin, as we said earlier, is pin 7. The LED pin is 36, and the water valve or water pump pin will be 16. Interesting note here, I originally had this on pin 12, but it turns out pin 12 on my Pi is broken and it's producing unreliable results, which I spent hours trying to figure out, and then I just switched the lead over to 16, made some program changes, and it started working immediately. So note there, if you have a Raspberry Pi and one of your pins isn't doing what you think it should do, try switching it over to another pin carefully and seeing if it fixes your problem, and if so, you may have a flaky pin. It's also a sign that your Pi is going to die. I know from experience, I've done this before. Okay, so that's the water pin. GPIO setup mode, we're going to use board mode. Here we declare the sensor pin, so this is going to be an input. I put this in here trying to fix the problem as I just described, pull up, pull down. This part of the command is not necessary. GPIO setup, this is the LED pin, and this is an output, and again this is the same thing. I was trying to fix that problem, but I started out as low, so in other words it's a 0. And GPIO water pin, also an output, and again the same comment. Let's look at the functions, or in this case function that does most of the heavy lifting in this program. We're going to define moisture. We're going to pass it sensor pin, so in other words we're going to be polling this sensor that's in the ground, and we're going to get the date and time, and we're just going to go grab it using this routine. It's the hours, minutes, year, month, day, and then the last thing, that %A, is the day of the week. We're going to pull out day of the week out of that. I'll show you what for in a minute, and then we're going to look at the time now, so we're going to grab the exact time right now. We're going to break out year, month, day, hour, and minute. And now we're going to get on to the logic. So this is more of the setup of getting the variables and the information we need to go on. If the GPIO input of the sensor pin is true, in other words, if it's dry, we're going to print the soil is dry and then the time date. Okay, GPIO output is the LED pin, so we have that. We're going to turn on, basically this says, we're going to turn on the LED if the soil is dry. Now this is not yet turning on the water valve or the pump. This is just merely telling us it's turning on that LED to tell us, hey, the soil is dry. So now what happens is we drop down to this if statement. Now, if it's after a certain time of day, and we set this usually for nighttime to preserve water, you don't want to water during the middle of the day because you lose a lot of water during evaporation. So we're going to set this nighttime such that, say, after 6 o'clock at night or something, so that the pump will only come on to water after that time period. And that again will save us a lot of water. Okay, so the LED will come on during the day saying, hey, it's dry and the pump's going to come on later, and then this will actually turn on the pump later. This second thing is another command that expands that one step farther, and that will add day of the week. So if you only want to water in the evenings on Thursday nights, because you don't want to overwater. You don't want to like water every night for most plants, because then the roots will rot. But yeah, if you want to constrict this to a day or two, then you can use this type of logic. Okay, going on, print water on. So now we're actually going to turn the water pump or water valve on. And here's where we do that. We're going to make the water pin high. And yeah, so the water comes on. Otherwise, if it's already wet, if the sensor says, hey, it's already wet, maybe it's been raining, or maybe the water's already turned on, and finally the ground is now wet, it's going to say, hey, print soil wet and water off, and then the date time. The GPIO is going to turn off our LED, and then it's also going to turn off the water pump, and then it's going to return back to the main routine. And scrolling down to the main routine, this is a rather trivial routine. First of all, it prints a user command. It says if you want to stop this program nicely, hit Control-C and it will quit. And then this handles that logic of the Control-C logic. So normally what's happening is it's got this infinite loop. It's going to come down here. It's going to do this infinite loop. And it's going to just keep calling our routine, the moisture routine. And then it will come back. It will sleep for 3 seconds. Now you can change this, but this is how often it's going to go up and do that function. Then it's going to come back here, do the moisture, sleep 3 seconds, and just keep doing this until someone hits the Control-C, and then it's going to come down here and do this exception, in which case it will exit this loop. It will say, okay, I need to do the GPIO cleanup, which turns off all of the GPIO channels, makes sure that like the water pump isn't left running or the water valve is left open. And then it prints done to tell you that yes, it exited nicely. Well, that's it for our video on how to use a Raspberry Pi to control a water pump for irrigation, for watering your lawn, watering plants, what have you. It could also be, with some small modifications, a way to check the water level in a fountain to make sure the fountain water pump doesn't go bad. You could have different probes to look for wet surfaces to set up warnings. And you could do things to check to make sure that your basement's not flooded, and take certain actions depending on what you needed done, turning on pumps, warning lights, maybe even dialing your phone. Okay, well that was it. I hope you found it useful and interesting in your Raspberry Pi experimentation and your gardening work.